Hello, welcome to the third video in this series where we're making Minecraft using Python, and that's with the Ursina engine coded by Peter Amland. And yes, we're in tutorial 3, and hello, I put the video of my face on. Sorry if that ruins everything, but I'll see if sometimes it's more helpful for me to be able to explain things with my hands and my face. So there we go. Right, what we do in this video, we are 0. Corrections from the previous video. Then number 1, I'm going to show you how you can move a mob's face and body to turn and look at you. So we're beginning to do some AI and looking at non-player characters interacting with us, so getting animals moving and things like that. I want to look at the colors of the terrain that we've generated. Oh yeah, with this little nmap mapping function, so that we can get the higher the terrain is, say a certain color, and then add some random in. So we've got some nice colors over our terrain, and I use the random range function in there. And then I want to do some building and mining, or at least deleting the blocks that we've created and then changing the block type. So that's what I want to aim to do in this video. Right, so first let's just correct what happened last video. So I'm just going to press play and remind myself what we got to. So it's very jittery, and I've fallen already through the terrain, and the terrain is at least being generated. So I'll press escape to come out of that. So I did put a comment in video 2 of what I forgot to do as I was hurrying to finish off in the last video. And that is around line 42, 43. Again, if you're not using your own code, you just want to use my code, I've got a link in the description for that. So this code, as it is now, is in the previous video, obviously. And when we change all of this, I'll put a link to what we do with the code in this video as well. So on this line, we're saying basically if half a second has passed, go and generate a new subset, so a new line of the terrain. What I then forgot to do was to reset what the previous time is. So basically what's going to happen is every update is trying to generate a new subset, and they're kind of getting in the way of each other, and that's why all that glitch, all that kind of, why it was slowing down a lot. So what we now want to say is previous time equals now, and to get the present time, you just write time.time. So then, next update loop, it's going to say, if now minus previous time is greater than half a second, which it won't be, because the updates are happening 60 times a second, something like that, even higher sometimes. So it's going to have to wait until it generates a new subset. So I've saved the file, and let's just see if that stops us glitching so much. Yes, so now we've got our 60 frames per second, and we are generating the subsets, lines of the terrain, as we expected, every half a second. So my frame rate's now dropped to 27, and that's maybe because perhaps we're trying to generate too long a line in our terrain. So maybe we want to do less, a subset being smaller. The smaller we generate each subset, the quicker we can kind of generate them, and the less of a jolt will happen. Although, perhaps depending on how much RAM you've got, you'll see less of a jolt. But anyway, when they're finished, I'll just stay in the game for the moment. When they're finished, so we'll have I think we're doing 100 by 100, I can't remember. Then we're going to combine all the subsets, and so now there'll only be one object. So we should get our 60 frames per second back again, and everything will be lovely. So while that's happening, let me just have some tea. Good morning, by the way. I'm recording this in the morning in England. And it's a little cloudy, but we should have some sun. So now it's combined. I'm actually looking at 30 frames per second. Oh, dropped to 9. What's going on? It feels nice and smooth. I think what might be happening is another little mistake that I've made. So I'm loving it. It is very smooth though, and it is now. I just want to go and like play this. I just want to like jump around and explore things. And just while I'm talking about this, I think the key thing about Minecraft or games like it is being able to have a really large terrain where you can just go and explore. And like the mathematics that's procedurally generating that noise function, the Perlin noise function, is truly like mysterious. You can go and discover new things that no one's ever seen before because of the combination of your seed and then other things we might do in the terrain. So later on in the series, we'll have fun like making biomes and things. Anyway, let's go and sort out that second mistake. So that's the first one. I forgot to do the key thing there to make the timing work. The other thing is, yeah, I just noticed I haven't done my indentation right here, where we're updating to see whether our subject, our player, has moved more than one unit. Only then do we generate a shell. But because I haven't put it on the correct indent, that was also happening every frame, I believe. So that may be slowing things down. Just to test, let's make our terrain smaller. So yeah, we did have 100 by 100. So is that 10,000 blocks? So it's quite a large terrain running at a good speed. So we'll just do 10 by 10. And yeah, what we could do, if we still wanted 100, the width of our terrain to be 100 or 400 or whatever you want, you could then make the subset width smaller than that. So maybe divided by 10. So it's then only generating 10 of them at a time. Actually, let's just go and have a look at what happens there. It should mean there's less. Whoops, what have I done there? Type error, float object cannot be interpreted as an integer. So what that means is that we're using subwidth, I believe, in a for loop. Yeah, there we are. And that needs to be an integer. So what we could do is just say cast that as an integer. So put some parentheses around it, say int, and that makes it an integer. That's the kind of thing you do if you wanted to print something out to the console and you use the print function and then you want to put a number in there but it won't work. You would then use str to make it into a string and then you'll be able to print your integer or your float. Anyway, as an aside. So I've saved the file again. Let's just see if this works now. Oh no. Subwidth is still being interpreted as an integer somewhere. Line 73. So I'm also using it, yep, here, line 73. So I don't want to keep having to cast it as an integer up here. What I should do is cast it here, and then I only have to do it once, and I don't have to keep going changing around my code later on. So that'd be the better way to do it. Now, it should run. Let's have a look. Yes, so we've got Mr. Goose. Oh, that is noticeably smoother. 69 frames per second. 69. Right. I seem to be stuck for some reason. Oh, that's because I was pressing E. I wasn't pressing W. Oh, this reminds me of something. Remind me in the comments later on if I don't get to this. But I wrote some code so that when we're walking forward, we can step up instead of having to jump. And it's, I don't know, I found it much more enjoyable to move around my different terrains. So if I don't get to that in like the next video or something, let me know. And that's using ray casts to negotiate the terrain. So yeah, so it's now generating this terrain more slowly because we're only doing 10 by 10, but it's still working, which is nice. It's still filling up the terrain as we want it. Although I've still got that 30 frames per second. It should be 60. I can't remember what I'm doing wrong. There's something else that I'm not doing. Anyway, let's put the terrain width down by 10 so it generates a lot faster. Also, we can actually ask it to generate a lot faster. So let's make it faster by 2 factors. So that's very fast. Let's just see if we can handle that. Yeah. So it's generating, whoop, and it's done. Oh yeah, and we're only doing a 10 by 10 terrain. Okay, my frame rate seems to be back up. No, it's dropping down again. So it's either my recording is doing that or I'll discover it. No, it's back up to 60. Okay, so let's just make the terrain width 100. I just forgot that I moved it back to 10. Let's just see how quickly. Look at that. That's really cool. It's generating a lot faster, although we're a little bit juddery. So maybe 10 cubes at a time is a bit too much for my computer anyway. But it's still playable at the moment while it's generating. So we maybe want to do about 4, a sub width of about 4, and then it will be fine. Anyway, right. So let's have a look at our list. Corrections times 2. So yeah, we've corrected those, which was generate the shell only after we've moved one unit. So that was just an indent. And then this was a big mistake. I forgot to reset like a timestamp the last time that we generated a subset, so that it was indeed happening after whatever duration we put here, or interval we put here. So I might just put 0.05, so we get slightly better performance there. Terrain width, I'll keep it 100 for now. And then, how big is our shell? I think we can reduce that. Shell width 6, so it is very small. Let's just put it down to 3, so it's incredibly small. And the other thing I wanted to do was, so basically, sorry, just to explain what I was doing there. So the shell, if you haven't seen the other videos or if you've forgotten, is the area with an actual collider, so an entities with a collider that's derived from the same noise function. So it's syncing with the terrain that we can actually see, and it's just moving with the subject, so that we've always got like a platform to stand on. And I've made that even smaller, so instead of 6 by 6, so 36 cubes, now I made it by 3 by 3, so 9 cubes. And so that's 9 is smaller than 36, so it's even faster for the computer to kind of compute. Although it's kind of a small difference, so we probably won't get too much of an improvement. But an improvement is an improvement. So the last thing we wanted to do at the top, this first thing is, right, create a safety net. So if we're performing large operations like combining all of those subsets together, so that's involving all these vertices, all these corners and triangles that make up the 3D mesh, that's making the computer kind of like lag. And when that lag happens, that can interfere with the physics that's going on, which means we might glitch through the terrain. And if that was happening many times, what we could do is maybe set up some inputs. So we press a button and that brings us back to the height of the terrain. Or we could just ask the following question. I think this is the way I'm going to do it. So in the update loop, in the update function, I'm going to say if the subject's y position is less than, let's say, -10, or minus the amplitude. So the amplitude is the maximum height, and therefore perhaps the maximum depth or lowest point that our Perlin terrain might generate. So if we detected we've actually fallen through, and let's just add 1 to that just to be safe. So if our position has got that low, then we need to kind of move the subject back up to the top where they should be. Then we're going to say subject y equals, and now we want to know, what height to be at using the Perlin noise formula, which is here. So I'm just going to copy and paste that. I've lost where I was. Am I up here? There we are. So my y, my subject's y wants to be noise at their x and their z. So x and z we were using for like block positions in a grid. Now we want to refer to the subjects x and y. And because we're in parentheses here, I can put, sorry, my helpful notes are getting in the way. I could go over to the next line. As long as you're in parentheses, you can do that in Python. So I need to turn off those like helpful hints, don't I? But I don't know how to do it, so I won't do that on camera because I'll just... or I could pause the video and then try and switch them off. Subject Z. So I might do that later if it gets too annoying. Right. So that should go and work out whatever position the subject is at. Move them up to where they should be, and actually we should maybe go one square, like 1 unit up. Well, no, we need to add the subject's height. So remember, our subject is an Ursina prefab. Specifically, we are the first-person controller. That, I think Peter Ameland coded this. It's a prefab. And so it has one of its properties, like cursor or gravity or its X and Y position. One of its properties is the height. And I think that's set to 2. So it's like 2 meters. So, I don't know, what's that, about 6'4", something like that. Maybe a bit shorter. Anyway, so we've got our subject position there. And I am going to add another. I'll just put +1 at the end. There we go. So that should kind of drop us back onto the top of the terrain. But then what I've noticed when I did that, sometimes the speed that we were dropping at is still applied to the player. So we kind of like slam into the terrain if we're lucky. If we're unlucky, we just glitch through again. And the gravity, the acceleration is just, what's the word? Accruing, getting bigger and bigger. So it just keeps glitching us through. So there is a function or a method for the first-person prefab controller, which is called land. And that basically says, okay, now we're grounded and take off all of your speed. So actually, maybe I'll take off the maybe I'll take off the 1 and see if that's fine. Anyway, so this is our safety net. And let's just label that, let's just comment that. Safety net in case of glitching through terrain. Smiley face. There we go. Right, so that's our little hack in case we glitch through. It's not a proper solution. Proper solution should be when we're combining all the subsets, freeze the player or something like that. Anyway, that's what I'm going to do. If you've got a better idea, or you manage to actually solve it, put the code in the comments. That'd be helpful for me and for other people. Right, that will do us for now. So, next thing on the list. We've done this one. Tick. Look at target. So, I'm cancelling the X rotation of our mob. So, down the bottom, yeah, we've got Vincent, who's our giant chicken. And he's kind of buried a little bit, isn't he, in the terrain at the moment. So let's go to a different terrain, shall we, just for now. So where's our Perlin noise? And then we might be able to see him a bit more easily. So we'll put the amplitude up to, I don't know, 24. We'll keep the frequency at that. Octaves maybe up to 4. Do we still want to be 2021? Maybe we'll go to 99. What does that look like? So our seed is 99, octaves 4, amplitude is quite small, frequency 100. And remember, the frequency kind of smooths things out. And we'll be happy with this if we can kind of see Vincent. So there he is. And what we want to do... Oh, I just fixed my terrain, and now I'm glitching through already. Although I didn't fall far enough. Okay, so yeah. Vincent looks like he's going to be very visible. So what would be good is if we could get Vincent to kind of turn his head and look at us. Like I showed you with a creeper in the first video of this series. Okay, let's do that. Right, so in the update loop, in the update function, we'll do this under our safety net. We'll just get hold of Vincent. There he is. And we can just use this inbuilt function from Ursina, so again coded by Peter Ameland, of look at. And that just means, could you turn the entity, Vincent, towards another entity, and that'll be us, the subject. So here we go. We'll say subject in the first parameter, and then we need what axis to use, and that means, do we want the back of his head pointed at him, or like maybe his feet pointed at us? We want the forward axis, so his face to point us. One problem might be certain models that you'll get will be kind of like flipped over and things, so their forward won't actually be the forward that you're interested in. And I don't know if we can do this. Can we just times that by time delta time? And then maybe by a scalar to make it happen more slowly. We'll see if that's right. Anyway, this time delta time means move this, or do this function, do this like, what's it called? A kinematic movement. That means like moving things without the physics engine in 3D space at a rate that's relative to how fast the update loop is moving, so how many frames per second you've got. And that means when you're playing this on a different computer, and maybe it's a slower frame rate, this time delta time takes that into consideration and makes it the same rate on that other device. So that's what you should apply to anything that's kinematic. So let's see if this is already working or breaks our code. Yeah, I can't apply the delta time there. So I've got to apply that maybe as another argument later on. Anyway, we'll just see if this is working first of all. Have some more tea. Okay, definitely working. We've now got a giant goose just staring at us. And as we move around, he is continuing to look at us. Brilliant. So that's how you can get your mobs looking at us. Now it's kind of cool if you've got a mob who's in the air. This shouldn't be in the air, but maybe you've got a ghast or something like that that's floating around, I don't know. Then this is fine, perfect. If you've got a grounded creature, then it means that their whole body will kind of like tilt into the floor, and we don't want that. So we kind of want to take out their X rotation. We want to keep their Y rotation because that's turning around, but we want to zero out the X rotation. So after we've used the look at function, we can then say, Vincent, can your rotation on the X-axis be cancelled out? And then he'll just stand up straight and look at us. Let's move Vincent down so in fact he's not flying. So after we've created Vincent, we create him 7.1 units in the air. So let's try about 2. I'm not sure. This might put him further into the ground. As long as we can see his face, we're happy. We can see his face. Yeah, now he's looking at us, but he's, and I'm going to go on to some high. I've got the high ground now, Goose Man. I've got the high ground. Watch out. Now he's, so not leaning into the ground or anything like that. And I maybe need to lift him by 2 meters, 1 or 2 meters. Brilliant. Okay, it kind of looked better, didn't it? Because of his size, actually leaning forward. So, useful for me or useful for you, the cancelling out the X rotation, but I might just comment it out now. Oh no, I'm using like JavaScript or C. There we go. Python. Hashtag is to comment out a line. Right. So we've done number 2. We've done the X rotation cancelling out and looking at the target. But I didn't. What I maybe need to look at is slowing it down if you want it to go slower and things like that. Okay. Right. Colors with nmap and random range. So we want to apply colors to our terrain, and we can do that for each individual block. What did I call it? Each individual subcube. and that won't be removed even when we combine each of those cubes into a subset and then combine the subsets into the whole terrain. That coloration will remain. So we want to do that when we're actually generating the subset. And so in generate subset, what we're then doing is going over every subcube in the subset area. We're determining its x and its z location, and then the crucial thing is we are determining its height, and that's how we get our terrain. Then we're saying its parent is the current subset, and that will mean that we can combine it into the subset to save performance. And then we're just setting its color to green here. And then we're saying it's no longer visible, so that green and its own texture, its texture will be white cube by default, I think, won't interfere with the overall terrain's texture. So that's important. But even though we're setting it to invisible, we can still set its color. So you'll notice that this Y value is slightly differently colored in my text editor. And that's because I'm not actually using it. But I still wanted to create it because I want to use the height, the Y value, to determine the color. So our color is going to be, let's just say for now, color.rgb, so red, green, blue, and we'll just say a red amount, a green amount, and a blue amount. And so before we do that, let me just add a set color of subcube, big smiley face, because colors are fun. And then we want to create R equals 0, green equals 0, blue equals 0 for now. So it will be black at the moment. And then what we want to do is something like green equals like Y. So the amount of greenness is the height of our cube. Let's just go and have a look at that at the moment. You can kind of imagine what it might look like. Oh wow, it already looks pretty good. I didn't expect it to take off the texture of our like subset. So I think because we've changed the color, that's removed the subset's texture. But when we combine the whole terrain, we should have our overall terrain's texture reapplied, but with the kind of like a height map underneath. I'm a bit confused why it's kind of like dark green up here and light green down there. Weird. Well, I know there's fog as well. Again, I should have made the terrain a lot smaller so this loads more quickly during testing. Just enjoying the view. Oh, another note, at least it was very playable while we're generating terrain. Another thing I could have mentioned was that I'm just making like Minecraft in it on the side as well, not in tutorials yet, but I found a way to generate an infinite terrain on the fly. So similar to what we were doing with the shell. Oh, well that's disappointing. It's I've now broken it. The texture hasn't been applied. So let's go and sort that out. but at least we've got different shades of green, although we can't really see the difference very well. And that's because our terrain is kind of going from maybe minus the amplitude, whatever that was, to plus the amplitude. But that might not really fit in terms of this component of the color RGB value. We want to go from maybe 0 to 255, but maybe go from 80 to 255, so they're not fully black. And so we need to kind of map the range of our terrain, so that as determined by the amplitude, to the range that we want for that green color component of the RGB value, which will go from, as I said, maybe 80 to 255. So we've got to map those two together. And there's a function that I'll show you that can do that. Yeah, let's do that first, and then we need to go and sort out what's gone wrong with our textures here. Right. Okay, so the map function. I think I've got the map function included in my prepared code. Here it is. Yes. So let me just go and copy and paste this code. I'm not going to be able to remember this, so I'll just go through it. Right, so you can put this maybe, actually what would be better is to include this as its own file. So let's do this properly. So I'm going to create a new file, select my language as Python. There we go, paste that in there, and then save your text file in the same folder that we're in. So here I'm in my tutorials folder. I've got tutorial 1, 2, and 3. So that's what I'm currently writing on, running. So we need to place this file in the same folder, or within a folder. Oh no, maybe just put it in the same folder to be fair. And let's call it maybe nmap.py. So we're writing a module, in other words, called nmap.py. Save that. And now, back in our main module, Minecraft module, we need to, let's just say, from nmap, which is the file we just wrote, import nmap. There we go. Because our function there is called nmap. There we go. And let's save that. Right, now let me just show you the function itself. So what this does, this function, it takes in a value and then it maps it to the min and max, so the last two arguments of another range. So we can take the y value of our terrain and we can say, well, that goes from minus amplitude to plus amplitude, and we want to map it to the color range that we want. And I said that's about from 80 to 255. And then it will do this little bit of maths, which is like the original value minus your first minimum divided by the maximum 1, or the difference between the maximum 1 and maximum 2, multiply that up by the difference between maximum 2 and minimum 2, add on minimum 2, and then that maps the two values. So that's how a map function works. There's probably one built into NumPy or Math or something that I just didn't discover. So I think I've imported it correctly here. I think I can use the same name. Let's just go and see. If not, we've learned something new. Right, go into, generate subset. And here where I'm determining the R value, the green value, the blue value. And now we want to say, actually, the green value equals nmap. Take the height of our block, and that can go from minus amp to amplitude. And we want to go between maybe about 80 to 255 is like the brightest green. And so that value then will be plugged into our RGB. Okay, right, the other thing we wanted to sort out was the texture. And you can probably see by my face, I'm not 100% sure what was happening. So the only thing we changed was we've set the colour to an RGB value instead of, what did we have? A built-in green value. And for some reason that overrode the texture, the grass stroke texture up here. So maybe what we need to do, let's try, oh look, I've got application pauses and resumes. Oh yeah, that was my first hack, to try and pause the app to stop glitching through the terrain, but I don't think this works. So we can take that out, apologies. Oh yeah, and I'm also, setting the height of our subject to 32. So that's kind of disrupting our safety net. So I need to delete that. So it's a good job I came over here. There we go. Let's just see what's happening. In the finished terrain, if the terrain is finished, then it returns. So it's not trying to combine all of the subsets over and over again. Then it combines and destroys the subsets. And then it's setting the texture of our terrain, although that's not working for some reason. So I need to maybe set this texture somewhere else. And I don't know where. Let's have a look. Let's try. Auto destroy is false. Let's just try setting the texture, I don't know, before we combine all the subsets, which are children of the terrain, into the terrain's one mesh. Right, at the very least, we'll be able to see whether our color mapping has kind of like worked. Oh, it's worked already. That's weird, isn't it? I don't really know why that's worked, but it has already. So we can see lower down we've got fairly dark green, and it looks like the higher values are greener, but maybe that's just an effect of the fog. You know what? They don't seem that much brighter, do they? So I think we need to go, our lookup function is definitely working, so I think we need to go and, oh, I know what's also happening. The texture itself is green, and I think we're just looking at the texture. There isn't a difference. The only variation in the colour we're getting in our terrain is from the fog. So, oh, good news is we've got Vincent standing on the ground, so that's one thing I achieved. Okay, so first thing I need to go and do is change the size of our terrain. So it's only like 20 or something, so that we can do the testing a lot quicker. Also, I think our map function was working because we didn't, and we've imported it. We didn't get any errors there. That's the other place where the bug could be. Maybe that wasn't working correctly. But I think it's more to do with this texture, grass stroke text. So what we need actually is a white text or a monochrome texture. And I can't remember if I did that last time. So that we can set the color of things, and then as long as the texture is white, the color that we set the entity to will kind of like shine through that texture, which is really handy. So where am I making my textures? Oh, so we've only got one texture, which is our grass texture. So let me just load up my assets. So what looks like I've already prepared for this video at some point. I've got two other textures here. I've got grass mono, so you can see it's monochrome, and then I've got stroke mono. And the only difference is stroke is this white line around. This one, although there's a white border on here, that's just in my operating system, just on the Mac. The actual texture doesn't have a white border, but this texture does. And so maybe we'll we'll use that one for now. So that's called stroke mono. So again, I've put these in the assets folder, which is in the same folder as where you're running the code from and where you put the nmap module file as well. So as long as they're all together, they'll all be able to communicate and work fine. So I forgot the name. Stroke mono. Let's go and make that texture. So we'll just call it monotext equals load underscore texture stroke mono dot png. Now I wonder if I just set the subsets terrain to that, will that sort out the color issue? Will we be able to see different colors at different heights? These do look a different color, but I don't see any. Sorry if this is really noisy. There's planes going overhead. Wow, that sounds really noisy. I'm actually vibrating. Oh, there it is. It's not a plane. It's a helicopter. In case you wanted to know. Right. So I've still not got any variation going on, and I think that's to do with where we're applying the textures. So let's just comment that out. So our subcube hasn't got a texture, and are we getting lighter green at the top? I think we are. We could see, yeah, definitely where the combine function there worked. Let's just stretch this right out. So maybe we'll go from 0 to amp, and then go from 0 to 255. So that should increase the variation. We should go from black to green. Oh, there we go. In fact, I didn't do that too skillfully. Okay, so we're definitely seeing green at the top. So our map function is working. And yes, we've got the texture now. And definitely the texture is working now in combination with the color. So I just need to fiddle this. I need to be a bit more intelligent here. So I want to go from, actually the 0 to 255 was kind of cool. But we want to go, yeah, we kind of want to maximize the difference here, don't we? And minimize this distance. So we want to go from maybe, I don't know, 3. Well, it's got to be like a minus. We've got to go from like 0 maybe to amp minus, or amp divided by 2. So kind of dark in the lowlands. What's going to happen when we climb? Okay, yeah, now we're getting a bit more bright at the top. Lovely. Cool. And it actually looks like there is no texture on the lower ones because they're so dark, which is an effect you might want. So you can also have like different colors. So we could say like for the blue maybe, we could say if y is greater than, I don't know, greater than amp divided by 2.5 or 3, then blue component, and just for an example, I'm just going to set it to a number, but again, you could use the map function to have some more sophistication about this. I'm just going to say 255, so we get lots of blue. We could also say if y is, I don't know, 4, then r equals 255, actually all of them, red, green and blue, all equal 255, so that means we get white. And then I need to just say else map the green to the current height. So we should have like a white band going around certain things. Local variable b referenced before assignment. Oh right, so I've only just made it there, so I need to say b equals 0 as well. I'm really excited to see the white band. What if it doesn't appear? Oh, there it is. So this is a way you could maybe get snow if you put that at maybe the top of your mountain, and then you could maybe apply a different texture as well. Although that's going to get tricky. I don't know, like playing around with the textures is going to get tricky, but because we're using just one texture over the entire terrain, maybe you'd have to not destroy all the blocks, but we're going to have to. Oh, maybe if you just set the texture and the color through the sub block, and then didn't have a texture for the terrain, and didn't have a texture for the subset and the terrain, then maybe that would work. Again, oh, I've run out of disk space, so I'm going to have to stop the video. Oh no, before we're going to do mining and things. So I'll have to do mining in the next video. Damn, I'm really sorry. I'll see if I can make that today and maybe release it very, very soon. But there we go. This is how we can get different textures and colours on our terrain. Thank you very much for watching. I'll see you next time. Again, leave any comments if you have any suggestions or requests. Goodbye.